Hey guys, I'm going to make a video real quick for you. So right here's the spindle square. It's a photo of it. And like I was saying, this is the front of the machine. So this is a front view of the machine. This is the old spindle square. This is the center line of the bit. And then all you do is the operators push down. This is the old version. On the new one, there's only one of these. So on the one, you spin it over here to the left, you push it down, and that becomes your new zero. And then you spin it around to this side and it should be flat. And if it isn't, then you adjust this way, and whatever you adjust this way will equally affect the other side because this is an equal distance. So that should make sense to you guys. Conversely, when you spin the dial to the front of the machine, so out here 4 inches, because this is about 4 inches this way, your zero, if this is your zero over here, it doesn't matter where you start with your zero. If it's flush, this will also be zero, just as this should be zero, and just as 4 inches in the back should all be zero if it's all perfectly flat. Well, what happens is, remember going back to that pin, so now we're looking at the machine from the side. This is the drill bit. This is the pivot point of the back of the machine. This is, I think, 11 inches, okay? So if this is 11 inches to center, knowing that this device, remember it only has one of these, you would spin it around to the front of the machine. This is 4 inches, okay? And then you spin it around to the back of the machine. This is 4 inches. So that's where the dilemma is, because when you pivot this machine, this entire head, it's very heavy. If you go down this far, it's going to be a different distance here than it is in the back, because this is the front of the machine. Remember, it's doing this, okay, in the photo. So what he needs is whatever this is, and this is the center, and then here's the measurement here. There has to be some kind of equation where you would have a data point here, a data point here, and a data point at totally the front of the machine. And then this is your center line. Because if you measure this and it's 1/10 off, and you move it 1/10, this is going to negatively impact that. So he's wanting someone to be able to put those data points into a formula in the calculator and come up with, if I need to adjust this much or this one this much, how much is it going to negatively impact based on this being a different distance between this and there. There it is, guys. Hope that helps.